Hey guys. All right. So this is the supplemental unit where we're going to talk about, not unit, just lesson about residuals. This goes back to when we were finding the equation of best fit. Um, and a residual has to do with the distance between the actual point on the graph and the line. So we're going to talk about that today. So what I'm going to ask you to do before we even start off is number all the pages in the packet. If you downloaded it from the Google Classroom, then it's already numbered. But if you got one from class, it's not. So the first page would be 1, then the back 2, 3, 4, 5, and etc. So what we're going to do today, or this first lesson, is about estimating, calculating, and creating residual plots. This video is going to focus on what a residual is and how to find it by estimating it, and then how to create a residual plot. So we're going to go to the front page of the packet, page 1, that's posted along, and we're going to talk about it. So this is the picture on the first page, and just so you know, we use a line of regression or a line of best fit to best represent the data of a scatter plot. Now, a scatter plot usually is just a group of points, and then we use a line or sometimes other equations or other functions to best fit the data. Sometimes it's a line, sometimes it would be exponential, but today we're going to really focus on just a line of best fit or a trend line. It's a line as it goes through the data. Sometimes and many times the line does not go through any of the points of the scatter plot. That's just a note. So today we're going to look at and calculate residuals, and then we're also going to plot them. A residual is just the vertical distance between the data point on a line here and the actual line of best fit. The residual itself is just the difference between the actual value that's on the value of the point of the scatter plot to the point of the y value on the line. Each arrow represents each of the residuals for a scatter plot. So some are above the line, some are below the line. When we get into this, we'll notice that the residuals that are above the line would be positive, below the line will be negative. Okay, so now we're going to turn it over to page 2. So what we're going to do is we're just going to estimate the residuals. Now, these are not accurate at all. They're estimations. They're just purely by eyesight. So what we do when we're estimating is we go to the 0.5 on the x-axis. So that would be here, which associates with this dot here. And we want to figure out how far is that dot from the line. In my estimation, it's about, so you look there, it's about 0.3. It's not a whole half above the line. It's not a whole box above the line. It's about 0.3. Now we're going to go to look at 2. Now 2, you'll notice it's underneath here a little bit and the line goes under a little bit. So I'm going to estimate that to be about 1 whole unit below the line. And since it's below the line, we're going to put -1. Then we're going to go to the next value at 2.8. And that's really close to the line. So I'm going to just put like a -0.2 because it's below and it's almost touching. So what I want you to do is I want you to actually try and estimate the rest of the residuals. Pause the video, fill in your table, and then press play to see if your answers are close to mine. So these are the numbers I got when I was estimating my residuals. They're probably not accurate. Yours may be more accurate, but just to be consistent, I want to make sure all of our data is the same for when we go to graph it in about 2 minutes. So what I want you to do right now is just correct your answers because we're going to use this data to make our own residual plot. And it'll be a little bit easier if we all have the same numbers. All right. So what are we going to do to create a residual plot? First of all, we only use the first column from a table. Sometimes you'll have 3, including the y value. So you would definitely ignore the y. What we do is we only graph the x and then the residual. And it's sort of like on an xy axis, but we call it the x residual axis. So like you'll see here. So here's the x-axis, here's the residual. So what we want to do is we want to look at the lowest value in the x column and the highest value. And then we'll notice it goes from 0 to 8. So if we space it 1 box, you'll notice we have enough room to extend it a little more. So we'll spread it out and make each unit 2 boxes over. And then what we're going to do is we're going to look for the highest and the lowest residual. And we have 3 as the highest, and you have -2 as the lowest. So we're going to, 3 would be the highest. So to keep it consistent, we'll go from 0 to 3 and 0 to -3. Now what we're going to do is we're going to plot these points. We're going to start with 0.5 and 0.3. So we're going to go over 0.5, which is a half, and 0.3, because we skipped 3 boxes, is about a third, is right there. And then we're going to go to 2, -1. So we're going to go over to 2 and down -1. And what I want you to do is now try it on your own. Pause the video, plot the points, and see if your answer are close to mine. Does your residual plot look like that? Hopefully it does. If not, correct your answers. So what I wanted to make sure is that we're done with the first lesson. So I want you to pause the video, make sure you have everything correct. I want you to go to page 3 and 4 in the packet and now work on practice problems 2 and 3. When you're done, there's an answer key posted on the Google Classroom. I just want you to make sure you have the answers correct. If not, just message me with any questions. Have a great day, guys.